So basically what's happening here is the water, the material is hot enough that the bottom of the water like steams up and carries the rest of the water around on top of it, and it allows it to like roll around.
We're here today with Professor Harwood of UNI, the chairman of the science department. We're going to play with liquid nitrogen. Should be a good time. At the moment we're actually pouring it in to actually dip our hands in, do some fun stuff, and when I say fun I mean dangerous. Yeah, it should be a good time. Professor Harwood just gave us the idea of doing a very long splash, as one would to put out a fire with a bucket of water. There it goes.
Now you're talking.
Now it's science again.
Go one more time.
So now we're actually going to get into the beef of demonstrating this, where I will dip my hand into this liquid nitrogen, and due to the Leidenfrost effect, the liquid nitrogen will actually boil around my hand to such a degree that it never will really physically touch my hand. So I can keep dipping my hand in there so long as I give myself short times in between to recover, and I keep it in for very short periods of time. So here we go. As you can see, I'm fine, not frozen or anything to that effect. My hand is not shattered. I'll do it again here. Yeah, who says science isn't fun? There it is again. As you can see, it's actually bubbling around one's finger there. Yeah. There it is. We're going to do kind of a typical test here with liquid nitrogen. We're going to dip this inflated balloon in it. Just going to hold it in there for a moment. As you can see, the balloon is shrinking. This is because the molecules in the balloon, the air molecules, actually lose a lot of kinetic energy because they're dropping in temperature, so they don't move as quickly, they're not colliding against the walls of the balloon as much, thus giving the balloon this very shriveled, almost pea-like appearance, really. Yeah, just gonna let it cook in there a little bit longer. Just let it shrink down, completely deflate. So now I'm going to try something a little bit different and take it out, let it get some temperature back. As you can see, the balloon actually solidified. And now the balloon, almost by magic, is reinflating itself. This is because the molecules in the balloon are getting a lot of temperature back. They're moving a bit faster.
Why did it sizzle?
It's the liquid nitrogen stuck to the balloon boiling off. And as you can see, the balloon is almost all the way back to its original shape. It's a balloon again, instead of just this shriveled like lump of plastic and rubber. So we've actually smacked the balloon against the side of a table a few times. It has,
leaking?
that's nitrogen.
Could be.
Yeah, we think. As you can see, it's kind of shattered. It's yeah. Now, it is still gaining some shape back. As you can see, we've got some nitrogen boiling across the table there. Probably some oxygen in there as well, yeah. As you can see, the molecules are starting to move a bit faster again. There's actually some nitrogen stuck in the bottom of this.
Why is it running across the table like that?
That's another demonstration of the Leidenfrost effect. It's evaporating so quickly beneath it that it's actually able to float around on a cushion of its own steam. There it is.
I think that might be awesome. Nah, that's right.
Yeah. Yeah.
In case you want it.
So now that we've done the effect with one's hand, let's see what happens if it's something not quite as warm, such as this ping pong ball. As you can see, the ping pong ball is kind of steaming. That is actually the nitrogen in the air condensing around the ping pong ball, and yeah, we just sort of shattered the ping pong ball there. There's one half of it there, and the other half. Who says science isn't fun? So now I'm just going to have some fun here. There it is. So now we're just going to have some fun here. There it is. That was a balloon.
Deflate.
Yeah. Now, when we dipped it in the nitrogen, it actually solidified up pretty quickly. It's gonna start getting heat back here in a moment, and it will actually be rubber again. There it goes. There it is. There it is. And now it's rubber again.